So good day. This is lesson 2 on exponents and logs. Remember, we're talking about powers, which have a very specific vocabulary. A power has a base that is raised to an exponent. And we're going to focus on making bases the same and solving equations. So when I look at this first example, I look at the bases of 9, 27, and 81, and I recognize them as being potential powers of 3. So I'm going to go through and replace them with powers of 3 and then look to simplify. So I've determined that 9 is 3 squared, 27 is 3 cubed, and 81 is 3 to the 4. Now I've got to raise my power to that exponent and do some foiling and collecting of like terms. Let's see what that looks like. So I brought in the exponents to those powers. The exponents raised to an exponent. 4x plus 6 for the first one with that 2. The 3 changes it to a 9x minus 3. And the 4 changes it to an 4x minus 4. Then I did my numerator. I multiplied my numerators, which means I can add my exponents. And then my last step was to divide. So my final answer, 3 to the power of negative x plus 5. Let's move down. That same skill is going to be used here. I look at the left and the right-hand side of the equation of b and hope that 343 can be written as a power of 7. All right, so 343 is actually 7 to the power of 3. And on the other side, I have 7 to the power of x minus 2. Well, if the bases are the same, then what must be true about the exponents? Good thinking. The exponents must also be the same. So x minus 2 must be equal to 3, which means x is equal to 5. Now we can combine exponents with radical signs, so that makes things interesting. The next example, letter D, has a 27 and a root 3, and I'm going to try to convert everything to powers of 3. All right, on the left-hand side, I didn't have anything to do, but on the right-hand side, 27 is 3 cubed, and 3 cubed has to be multiplied by the square root of 3, which can be written as 3 to the exponent a half. My rule is add the exponents. 3 plus a half is 3.5 or 7 over 2. Either form is fine. Again, because the bases are the same, it must be true that x is 7 over 2. When we work with exponents and powers, we often talk about bacteria, and it's always great to also talk about money. This example talks about a bacteria that triples every 6 days. Now that tripling is seen in the 3 that's present in the formula. So that 3 is my tripling 3, and in this particular case, we're wondering how long does it take a population of bacteria to grow to 243 bacteria, usually colonies, if their tripling time is 6 days. So the tripling time, notice where that's sitting in the denominator of the fraction, and we've got the same skill as we had before. Can I write 243 as a power of 3? Think about that. So playing around on my calculator a little bit, I found out that 3 to the 5 is equivalent to 243, which means I now have powers which have the same base, which allows me to set their exponents equal to each other. And now I'm looking at a nice junior high question where what number divided by 6 is equal to 5, and that's 30. We've got 2 more examples to try with the similar skills. Can you try out A and B, and I'll catch up to you. I've looked at the first one. I started in blue or green. I started in blue. and replace the 27 with 3 cubed. I replaced the 81 with 3 to the 4 and was a little frustrated that's in the denominator. I multiplied the 3 and the x minus 2 to get 3x minus 6. I multiplied the 4 with the x plus 3 to get 4x plus 12. And then I shifted to working in green over here at the left. I need to move that power up. The power needs to move up, and it moves up by changing signs. And I've indicated that with a big minus 1 in front of the brackets. So now I have 3 to the 3x minus 6 equals negative 4x plus 12. The negative moves in on both. And then I've got a little algebra statement which might seem reminiscent of junior high, which is always good. 4x I moved to the left, negative 6 I moved to the right, and then isolated for x. I won't talk through quite as much the next one. See how that goes for you. Powers of 6 maybe, and powers of 5. So I've got to a spot where I think I'm good, but the bases aren't exactly the same. And what you can see is that on one side I have negative exponents, and on the other side I do not. So we can alter that by visualizing, bringing in the negative 3x to the 3x over 4 to both top and bottom, and then flipping that around. So this is what it would look like. So there are a couple of ways you can proceed with this one. I proceeded to show you over here on the side how I'm going to deal with those negative exponents. I put the negative exponents into the brackets and then suggested with that double-headed arrow they're going to flip positions. And in flipping positions, the signs change. So the 6 moves upstairs, the 5 moves downstairs, and then the exponent is positive, which now allows me to say that because the bases are the same, I can say the exponents are equal, which means 3x over 4 is equal to 3x minus 3, which is going to need a little bit of algebra. Try that out. I'm not sure what you're most comfortable with. I've got to move the 3x over to the left-hand side. I moved the 3 over to the left-hand side, and I've got to move the 3x over 4 to the right. So I'm going to go 3 minus 3x over 4, which is 2.25, or 9 over 4. So 9 over 4x. And then I'm just going to have to slide down a little bit in my work and get that answer. So x ends up being 4 over 3. A few different ways you could go about solving that. So now this is the lesson completed for lesson 2. Go ahead and find your pink sheet and try out the exercises. Thank you.